Okay, bismillahirrahmanirrahim. Okay guys, so untuk hari ni saya macam tadi saya explain balik tadi, saya akan review balik untuk analisis load on beam. Actually kalau kita tengok the basic of building construction lah, saya bagi tahu itu kita memang go to building lah. Nah, kita memang go to building construction lebih nampak. Okay, so apa analisis load on beam ni? As you can see here, kita ada one panel slab, kita ada slab A, B, slope 1, 2. So kita tulis dia panel A, B, slope 1, 2. Okay, ni kita ada slab panel A, B, slope 1, 2. So kita nak identify load on beam. So apa beam kita ada kat sini? Contoh bagi satu primary beam kat saya.
A stroke 1, 2.
Okay, A stroke 1, 2. So A stroke 1, 2 is primary beam. So let's say kita kata A stroke 1, 2 ni adalah primary beam. So bila kata analysis load on beam, kita nak buat beam. Okay, you nak buat bangunan, so nak kena ada beam as one of the structural element to support the load. Okay, on in the beam, in the building. So kita nak identify apa load yang ada. Okay, what kinds or total load on this beam. Kan kita nak tahu total load on this beam. Sebab apa? Bila kita nak design, kita nak buat reka bentuk, kita nak tahu size of rebar, reinforcement bar yang ada dalam beam tu, and also the diameter, size, diameter, and how many bar, how many number of bar required for this beam. So untuk design all that, kita nak kena tahu total load of this beam. Beam ni support apa? So as you know, beam support apa guys?
Support slab.
Yes, support slab. Okay, good. So beam support slab. Okay, lagi beam kita boleh kata support siapa lagi?
Self weight.
Yes, okay, beam support self weight. Kita kata beam support self weight of beam. Self weight. Lagi kita kata tadi beam support load from slab. Any more? Beam support apa lagi?
Dead load.
Roof.
Atas beam tu boleh ada apa?
Dinding.
Dinding. Okay, brick wall. Okay, roof. Okay, beam support roof juga. Tapi itu untuk roof beam. Tapi yang kita design ni kita tak consider roof beam lah. Sebab roof beam dia just support the load from roof. Tapi yang ni kita consider ground beam, kita consider first floor beam. Okay, so kita kata tadi ground beam dia support self-weight beam, dia support slab, and also dia support brick wall. So kita nak identify quantity ni lah, this value. Berapa self-weight beam, berapa weight of slab, berapa weight of brick wall. Itu maksud analysis load on beam. Okay. So now kita akan concentrate untuk beam, slab dan juga brick wall. Sebab kita nak analisis load on beam. So atas beam, kita kata tadi beam dia support berat dia sendiri. Okay, then dia support slab and also dia support brick wall. Okay guys, dah nampak nak? Okay, next. So for today kita akan go through two types of beam. Actually you dah very familiar with it. Okay, then two types of slab. Then safety factor for ultimate limit state design. Saya dah explain in previous lecture. And analysis load on beam, saya akan explain lagi how to find safe weight beam, design load beam, safe weight brick wall, design load brick wall, safe weight slab, design load slab, and how to sketch the load diagram of beam. Okay, so the first one is two types of beam. So as we know, primary beam. Okay, primary beam is a beam which is supported by column. Means at the end of beam there is a column. So kalau kita tengok kat sini, cepat, name it. List kat saya, primary beam. Which one is primary beam guys?
A stroke 1, 2.
A stroke 1, 2. Lagi? Okay.
C stroke 1, 2.
Okey, orang lain pula.
AC stroke 2.
AC stroke 2, okey. Lagi?
A
The last
stroke
one.
1.
AC/1. Okay, pandai dah. Semua dah pandai. So primary beam, kalau dia kata state the beam reference. This one is beam reference. Okay, beam reference kita baca dia punya. Kalau saya A lah paksi X, then baru kita baca paksi Y dia. Nah, actually mana-mana pun boleh. Tapi kita follow the standard lah. Senang, semua orang sama. Okay, so secondary beam. State the beam reference for secondary beam.
A1/12.
A1 stroke
A1
stroke 1, 2. Okay, boleh. Thank you. Okay, next. Okay, kita tengok two types of slab. So kat sini, as you know, kita ada two types of slab. One way spanning slab and also two way spanning slab. Okay, so untuk one way spanning slab, of course the ratio of Ly over Lx is more than 2. So please remember Ly is longer beam, Lx is shorter beam. Ly, Lx not refer to the axis. Nah, jangan silap yang tu. So once the ratio of Ly over Lx more than 2 is one way. Kalau saya dulu saya ingat dia terbalik lah. Okay, two way spanning slab is if the ratio of Ly, Lx is less than or equal to 2. Okay, boleh. Yang ni tak ada apa kan? Okay, next. Yang ni. Boleh nampak slide ni? Two types of slab again. Boleh guys? Respond? Kalau tidak saya hilang.
Boleh.
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 Okay, selalu soalan dia akan tanya kita macam ni. Sketch the 3x3 area for beam. Okay, sketch the 3x3 area for beam. Okay, apa maksud 3x3 area? Kawasan agihan kepada beam. Okay, kawasan agihan kepada beam tu, 3x3 area tu maksud dia how this slab distribute their load to the beam. Tu maksud dia. Sketch the 3x3 area means you have to identify either this slab panel are one way or two way. Okay, sketch 3x3 area. Dia tak akan kata identify, ni antara soalan Kalau dia kata identify the panel slab either one way or two way, senang. Tapi kalau dia kata sketch the 3x3 area for beam A112, ni beam A112 ni, yang ni, okay, beam A112 yang ni, so you means beam ni, okay, this beam A112 support slab kiri dan kanan dalam keadaan macam mana. Okay, so what are we going to do adalah you have to identify either this slab one way or two way. So first kita tengok panel A1 stroke 1, 2. Okay, so sini kita ada Ly over Lx is 6/6, kita dapat 1. So 1 is less and equal to 2. So kalau less than 2, one way or two way?
2.
Okay, two way. So you kena tulis two way spanning slab. Sebab yang ni ada markah. You jangan tinggal macam tu je. So you kena state this is a two way spanning slab. Then second panel, okay, then kita ada panel A1 stroke C, A1C stroke 1, 2. So kat sini kita ada Ly over Lx. Ly kita ada berapa? 6. Lx kita ada 2. Then kat sini kita dapat 3. So 3 more than or less than 2?
More.
Okay, more than 2. So one way or two way?
One way.
One way.
Okay, so tulis one way spanning slab. Okay, ini baru kita identify one way or two way. Once kita dah dapat either one way or two way, kita nak kena sketch the 3x3 area. Okay, how to sketch the 3x3 area? Okay. Okay, yang ni kalau you tengok this slab, okay, you tengok this slab dia square. Nah, dia square sebab sini 6 meter, sini pun 6 meter. Okay, sebelum ni yang kita buat rectangle. Okay, kalau rectangle dia ada shape triangle dan juga trapezium. Okay, this one square slab. Kita panggil square slab. So, bila square slab, two-way spanning slab. Okay, bila two-way spanning slab and the slab bentuk dia square. Okay, so all these 4 beam, okay guys, all these 4 beams, okay, all these 4 beam akan support load daripada slab. Okay, dalam bentuk apa? Dalam bentuk triangle shape. So daripada bucu kolom, daripada bucu bawah ke bucu atas, daripada bucu atas ke bucu bawah. So you draw the triangle shape. Okay guys, boleh? Guys, boleh ni?
Boleh.
Saya takut hilang. Okay, so maksud dia kat sini, setiap beam, keempat beam ni akan support load from this slab dalam bentuk triangle. Sama ke tak sama jumlah dia agak-agak?
Tak.
Sama.
Sama ke tak sama?
Tak sama.
Sama. Nah, sama nah. So kita kata kat sini actually dia punya degree, angle dia adalah 45 degree. Okay, angle dia adalah 45 degree. Jadi setiap beam akan support load yang sama, jumlah load yang sama. Okay. Okay nah. So you kena lukis arrow. Ingat tau, kena lukis arrow what for to show the load parts from slab to the beam. See, each beam akan support load from the slab. Just draw the arrow like this. Okay, ingat ini untuk square slab. Okay, then kita ada one way spanning slab. Okay, how to sketch the tributary area? You tengok LX dia yang mana? Sini 6, sini 2. Okay, pada side LX, you divide the LX side into 2 part. Bahagi pada 2. Okay, so sebelah distribute to beam A112. Another half distribute their load to beam C12. Okay, clear kat sini? Ada nak tanya? Tak ada? Proceed. Okay, next. Okay, second. Kita tengok sini. Again, the question is sketch the tributary area for beam B/12. This beam guys. Nah, this beam. Okay, beam B/12. So kita nak tahu this panel slab and also this panel slab, how they distribute their load to this beam B12. Okay, again, kita identify dulu either one way or two way. Kita tengok panel, you all buat, bagi tahu saya, panel A1 stroke B, A1B stroke 12, LY over LX dia dapat berapa? Sini kita ada LY, this one this one. LY is 7050, LX is 3050. So berapa dapat? Berapa dapat?
2.3.
Okay, 2.3 more than 2, right? So this is more than 2, one way. Macam tu, one way spanning slab. Okay, another one. Panel BC stroke 12. Kita ada LY over LX. LY dia 7650. LX is 7050. Berapa dapat guys?
1.1.
Okay, 1.1 is less than and equal to 2. So this one is two-way, right? Okay, two-way spanning slab. Okay, so bila kata sketch tributary area dalam soalan, bila you buat balik, you kena redraw lah. You kena redraw macam saya buat tadi tu. You kena redraw the figure. So let's say saya tak nak redraw. Okay, saya just sketch kat sini. So how they look like. Kita tengok panel A1B is one way. So one way ini LX dia kan. LX, so kita divide the LX side into 2 part and show the arrow of load part. Ini one way. One way sama je. Janji you divide, you bahagi 2 tu pada LX. And now panel BC slope 1, 2 is 2 way. Ini exercise yang saya buat sebelum ni ramai yang ramai yang confused kat sini. So kita tahu kat sini bila two way keempat-empat beam akan support the load. Okay, akan support the load. Tapi dalam bentuk apa? Before this yang square slab tadi, logik lah. Sebab bila each beam sama panjang, so dia akan support load dalam jumlah yang sama. Tapi this one 7650, this one 750. So which side yang akan support more load from the slab, guys? Which side? LY or LX? LY. Okay, betul? So LY. So untuk yang ni, again, LX kita bahagi pada 2. Kita sketch je guys, tak payah nak ukok-ukok. Okay, kita bahagi pada 2, then you tarik dia. Gitu. Maksudnya kat sini, okay, maksudnya kat sini, the longest beam akan support more load from the slab. Sebab apa? Dia dalam bentuk trapezium ni guys. Dia dalam bentuk trapezium. So bila dia dalam bentuk trapezium, nilai dia akan lebih banyak daripada bentuk segitiga ni. Yang triangle ni. Ni. So siapa yang buat sebelum ni? Member. Nah, ingat, the longest beam akan support more load. Okay? Settle? Ada yang tanya? Tak ada? Proceed. Okay. Next kita akan tengok ultimate limit state design. So apa dia ultimate limit state design? Saya dah explain dalam lecture sebelum ni. Di mana bila kita nak construct the building. Kita nak construct the building, of course kita tak nak our building collapse. Okay. So bila kita tak nak collapse, kita nak kena design dia the best one. Okay, the best one. So ultimate limit state ni maksud dia reka bentuk takat muktamad. Maksud dia kita kena design that element, that structural element, orang kata to the maximum load yang dia boleh support. Kita tak boleh agak-agak lagi. Okay, so under ultimate limit state design kita ada safety factor. Kita ada safety factor. Ingat kan? Kita ada safety factor. Apa dia safety factor ni? Cerita yang kalau kita masuk kedai RM2, kita tak akan bawa RM2, kita tak akan bawa lebih. Kita akan bawa lebih RM10. Kenapa kita nak buat RM10 tu? Kita standby for the next, orang kata the next plan. Ataupun kalau kita tengok pada building tu sendiri, kita tahu safe weight beam. Okay, kita tahu beam. Okay guys, beam you imagine beam. Okay, beam made of reinforced concrete. Okay, made of reinforced concrete. So made of reinforced concrete ni dia ada berat dia sendiri. Concrete density is 25 kilonewton per cubic meter, right? So ini adalah dia punya concrete density. Then beam tu sendiri dia ada cross section dia, area of cross section. Width and depth kan. So you nak dapatkan safe weight. Okay, safe weight beam ataupun dead load of beam. Okay, safe weight beam or dead load of beam. Ini yang kita kira directly from that element. Okay, directly from that element. Tapi bila kita nak buat, okay, bila kita nak construct the actual element, kita tak boleh consider this value. Kita tak boleh consider this value. Inilah yang kita panggil characteristic load. Characteristic load ni beban, orang kata beban mentah. Okay, beban mentah, actual load. So kita tak boleh pakai this value. Sebab apa? Kita kena consider environmental factor yang akan bagi effect pada our building. So that's why from this characteristic load, bila kita nak design the actual building, kita kena add on dia dengan safety factor. Okay. So kat sini saya list semua ni. Saya akan explain satu-satu. So first kita tengok dulu characteristic load. Characteristic load ni apa dia? Beban ciri guys. Beban ciri. Kalau ni beban mentah. Yang saya panggil lah beban ciri, beban mentah. Maksud dia. Okay. So apa dia yang dikatakan characteristic load ni? Dia adalah safe weight. Dia adalah dead load. Dia adalah superimposed dead load. Kan? Yang awal-awal dulu first chapter kita go through permanent action. Okay, physical forces. Physical forces kita consist of permanent action dengan environmental factor kan. So under permanent action kita ada safe weight dan juga superimposed dead load, right? Okay, safe weight tu samalah dengan dead load. Okay, so safe weight or dead load ni refer pada weight of structural element. Weight of structural element. Okay, safe weight slab, safe weight beam, safe weight brick wall. Cause of what? All that element are made of reinforced concrete. So dia ada berat dia sendiri. While superimpose dead load ni, superimpose dead load ni apa dia? Flow dia punya permanent fixture. Okay, permanent fixture. Kalau kita kata itu dalam satu bilik tu dia memang dah ada floor finishing, dia ada aircon, dia ada permanent machine. That one is superimposed dead load. Okay. So another characteristic load adalah imposed load. Okay, imposed load. Contoh imposed load apa guys? Contoh imposed load apa?
Person.
Person furniture. Okay. So person furniture pun semua tu kan ada berat dia. So kita refer pada Eurocode, dia ada dah nilai-nilai jumlah dia berapa lah. Okay. So tolong ingat safe weight, dead load, superimposed dead load, imposed load or live load adalah karakteristik load. Beban mentah, beban ciri, beban yang direct kita dapat from that object, from that load. Okay. From that element. Okay. So, bila kita nak buat design, saya kata tadi, bila kita nak design the actual element, kita kena add on dia dengan safety factor. Okay, so safety factor for ultimate limit state design, kita tak nak our building, kita tak nak our structure collapse, right? So, untuk dead load, ni dead load, kita kena kalikan dia dengan 1.35 kali GK. GK ni apa dia? GK ni refer pada karakteristik dead load. Ni karakteristik dead load ni atas ni, first ni. Okay, GK. GK is karakteristik dead load, safe weight, superimposed dead load. Itulah. Okay. Then untuk imposed load, apa dia punya safety factor? Kita kena kalikan dia dengan 1.5. Okay, 1.5 QK. QK ni apa dia? Karakteristik imposed load. See? Okay guys. So safety factor untuk design adalah 1.35 GK untuk dead load, 1.5 QK untuk imposed load. So selalu saya akan sebut direct GK, QK. You kena ingat GK is dead load, QK is imposed load. Okay. So again, ultimate load, design load, factored load. Okay, tadi kita dah tengok karakteristik, lepas tu kita tengok safety factor, then kita nak buat design load. Kan ada soalan design, calculate design load of beam, calculate design load of slab, calculate design load of brick wall tu apa dia? Kita nak buat lah. Kita nak buat the real element. So nak kena buat reka bentuk. So design load of beam sama dengan 1.3 GK. Kenapa GK? Sebab beam adalah dead load. Beam adalah dead load nah. Beam adalah dead load. Ingat beam adalah dead load. So dia adalah GK. Okay, then kita ada design load of brick wall. Okay, brick wall pun adalah dead load. Okay, brick wall pun adalah dead load. So, rumus dia 1.35 GK. Guys, are you with me?
Yeah.
Saya ingat saya duduk seorang-seorang. Okay, dan yang ketiga, design load of slab sama dengan 1.35 GK plus 1.5 QK. See? Kenapa ada 1.5 QK kat sini? Siapa nak bagi tahu kenapa ada 1.5 QK kat sini? Untuk design load slab. Sebab
Ada
apa?
live load.
Yes, ada live load. So tolong ingat, beam support diri dia sendiri. Brick wall support diri dia sendiri. Slab dia support diri dia sendiri, yang ni 1.35 GK, dia support diri dia sendiri. And also dia support imposed load. Nah, atas slab saja yang ada imposed load. Dan kita furniture, perabot apa semua whatever tu ada atas lantai. Nah, dia duduk atas lantai. Dia tak duduk atas beam, dia tak duduk atas brick wall. Okay guys? So logiknya kenapa ada 1.5 QK atas slab? Sebab slab the only structure element yang support everything. Okay, yang kita allocate everything on the slab. Okay guys, so please remember all this formula. So kalau dikata calculate ultimate load ke, calculate design load ke, calculate factored load ke, benda yang sama. Okay, term sahaja berbeza tapi maksud dia benda yang membawa maksud yang sama. Okay, Okay, next kita tengok kalau dalam soalan dia kata monolithic beam and slab construction. So saya ada bagi tahu sebelum ni. So what is monolithic beam and slab construction? Maksudnya kat sini bila kita nak buat konkrit untuk beam, okay, kita nak buat konkrit untuk beam, okay, kita nak buat konkrit untuk beam dan juga slab, kita tuang konkrit sekali. Okay, kita tuang konkrit sekali. Maksud dia tak ada pemisah. Dia bukan macam ni lah, kita tuang konkrit untuk beam dulu, lepas tu barulah kita tuang konkrit untuk slab. No, kita tuang sekali. So bila kita tuang sekali, kalau kata untuk this section AA, dia akan jadi bentuk T-shape macam ni. Kalau kita tengok sini. Ni section AA, you tengok section AA dekat beam A112 ni, kita ada beam cross section AA, mana kalau dia punya depth is 500mm, width is 200mm. Okay. So kat sini lah kita panggil monolithic beam and slab construction. Okay, apa maksud dia tadi? Saya kata beam and slab are constructed as one body. Okay, are constructed as one body. So dia punya depth tu, okay, dia punya depth given for beam include rib beam dan juga slab. Okay, ini rib beam guys. Yang bawah ni, okay, ini adalah rib beam. Apa dia rib beam? Rasuk berbibir. Rasuk berbibir. Kan bibir dia terlebih kan? Ni terlebih. Okey. Ini apa dia? Yang atas ni apa dia? Guys, apa dia yang atas ni? Apa dia yang atas ni? Hello?
Mana ada?
Ni yang atas ni, yang saya lightkan kat atas ni.
Slab.
Slab. Okey. Nah, so bila kata monolithic beam and slab construction, ketinggian yang diberi tu adalah consider rib beam and slab. Ada syarat dia lah. Sekejap kita tengok syarat dia. Okay, yang ni rib beam. Nah, rib beam. Kalau kata calculate separate beam tu maksud dia suruh calculate separate rib beam lah. Okay guys. Ni beam cross section untuk AA. Tengok ni. Beam. Kan sini beam. Ni atas lantai. So dia bentuk T. Kalau kata cross section BB, pada cross section BB ni, kita tengok sini. Ini beam. Okay, ini beam. Ini slab. Nah, ini beam. Ini slab. Ini rib beam. Rasuk berbibir. Okay. Okay. Kenapa saya explain yang tu? Ada sebab. Kita tengok yang ni. Okay guys, nampak soalan ni? Figure shows a layout plan of the floor plan. Nampak guys? Boleh?
Nampak.
Boleh saya proceed? Okay. Okay. So kat sini dia kata figure shows a layout plan of the floor plan of a monolithic beam and slab construction. Ni dia mention. Tapi ada soalan tak mention. Kalau dia tak mention pun tak apa. Tapi itulah yang kita buat. Monolithic beam and slab construction. Okay nah, ingat nah. So size of all beam is 500mm deep. Maksud dia, depth dia, tinggi dia 500. Okay, ni saya buat cross section ni nak bagi you all nampak ni. Okay, ini cross section of beam. Depth dia 500. 250mm wide. Width dia 250. Okay, nah, depth 500, width 250. And characteristic load on the floor are as follows. Imposed load 2.5. Floor finishing, concrete density and slab thickness are given. Imposed load ni apa dia guys? Imposed load, safety factor for imposed load apa dia?
QK.
QK. Safety factor dia? Safety factor untuk QK, imposed load apa dia? 1.5 ke 1.35?
1.5.
1.5. Okay, floor finishing kita consider as imposed load or dead load? Floor finishing kita consider as dead load or imposed load?
Dead load.
Dead load. Tu kena faham sebab dia sebut floor finishing. Floor finishing is superimposed dead load. Kena ingat yang tu. Okay. So sekarang tinggi beam adalah 500. Okay, so kat sini nampak saya dah highlight. Depth of beam cannot more than 350. Ada maksud dia. Okay, depth of beam cannot more than 350. Okay, macam ni tadi. 500, okay 500 ni adalah tinggi keseluruhan. Okay, tinggi keseluruhan guys. Okay, so bila kata calculate self weight beam, actually kita nak weight of rib beam. Rib beam sahaja. So kalau kata lebih pada 350, macam mana kita nak dapatkan tinggi rib beam yang sebenar guys? Bagi tahu saya 500, nak buat apa dengan 500 ni? Kalau nak dapatkan tinggi rib beam, 500 kena tolak dengan siapa?
Thickness.
Thickness apa?
Slab.
Yes, thickness slab. Tolong ingat. Tolong ingat kalau kata depth of beam given is more than 350, you kena deduct dia dengan slab thickness. Kalau kata 350, nilai dia 350, tak payah tolak lah. Nah, saya kata kat sini, more than 350, you have to deduct dengan slab thickness. Okay, so area of beam cross section. Mana dia area of beam cross section? This is cross section. Yang katakan cross section ni, this adalah cross section. Luas keratan rentas. Okay, kita potong dia, this one is keratan rentas. Okay, so beam cross section sama dengan width time depth. Okay, width dia kita tengok kat sini 0.25. Saya pakai dalam meter terus. Sebab per meter, kalau kita tengok sini, yang data given semua unit dia per meter. Nah, semua unit dia meter. So kita convert siap-siap. Width 0.25 kali dengan depth. Okay, depth tadi 500. So 500.5 kena tolak dengan slab thickness 0.15. Okay, kita tolak dengan slab thickness 0.15. So berapa you dapat guys? Area of beam. Berapa dapat area of beam?
0.0875.
0. Kita ambil 3 je lah. Kita ambil 3 lah. 0.088 meter square. Okay, settle. Ingat kita dah dapat area of beam cross section 0.088. Okay, next. Kita tengok sini, kita nak calculate self weight beam. Kita nak calculate self weight beam A1 ni. Ni, beam A1, 1, 2. Okay, calculate self weight beam. So, self weight beam sama dengan area of beam cross section kali dengan concrete density. Just now kita dah dapat area of cross section 0.088 times with concrete density. Concrete density is 25. Okay, concrete density is 25. So, from this, you akan dapat 2.2. Unit apa guys? Bagi tahu saya. Unit self weight beam. Apa unit self weight beam? 2.2 apa? Kira semua orang tak mau duduk saja.
Kilonewton.
Kilonewton sahaja. Bagi tahu saya. Kilonewton
Per
apa?
meter.
Per meter ke per meter square?
Per meter square.
Per
meter square.
Per meter square. Betul ke tak? Beam.
Per meter.
Unit beam. Kilonewton per meter ke per meter square?
Per meter.
Per meter. So again, please remember. Please remember self weight beam is in per meter. Self weight beam is in per meter guys. Kenapa? Sebab beam dia sempit. Dia kecil. Dia punya width dia. Okay, dia punya width dia is less than the depth. Apa cakap tu? Width dia less than depth. So bila width dia less than depth, unit dia adalah kilonewton per meter. Kita measure dia per meter. Kita measure dia per meter. Okay. Then calculate design load of beam. Okay, kita tengok design load of beam tadi. Okay. So design load of beam sama dengan 1.5 GK. Okay, 1.5 or 135 guys?
1.35.
Yes, 1.35 GK. Okay, kira semua. 1.35 GK refer pada self weight beam. Okay, GK is 2.2. So, berapa kita dapat kat sini? Kita akan dapat, saya kira dah tadi, kita akan dapat 2.97 kilonewton per meter. Betul ke tak? Dapat semua orang?
Betul.
Okay. So next kita tengok brick wall pula. Okay, kita tengok brick wall pula kat sini. Dia tambah lagi, dia kata kat sini. A 125 mm thick brick wall with a height 2.5 meter is constructed along beam A1 slope 12. Again, atas beam yang sama ada brick wall guys. Ada brick wall. Brick wall tebal dia 125. Ni saya sketch kat you all ni. Ni tebal dia 125. Okay, 125 mm. Again, dia kata height of the brick wall. Height of the brick wall is 2.8 meter. 2.8 meter. Wall brick density is 18 kN per cubic meter. Okay, so kita calculate safe weight. Calculate the weight of the wall. Okay, calculate the weight of the wall maksud dia calculate safe weight lah. Sama. Calculate safe weight brick wall dengan calculate beam, rumus dia sama. Sebab kalau kita tengok bentuk dia pun sama kan. Bentuk dia pun lebih kurang sama. Cuma brick wall ni tinggi lagi. Itu je. Nah. So rumus sama. Jadi area of brick wall. Apa dia area of brick wall? Apa kali dengan apa guys? Beritahu saya.
Width dulu madam.
Width dulu. So width dia 125 mm. Write down in meter nah. Ingat nah. So 0.125 kalikan dengan 2.8. Okay, this one is area. Nah, this one is area. Ni area of brick wall. Okay, then kita kalikan dengan apa tu? Brick wall density 18. Nah, so berapa you dapat kat sini? Okay, semua orang buat. So kat sini kita akan dapat 6.3 kilonewton per meter. Unit pun per meter. Sebab brick wall dia kecil. Width dia less than the depth. Nah, so 6.3 kilonewton per meter. Check guys. Okay, so design load of brick wall. So dia adalah dead load. So just 1.35 GK equal to 1.35. GK kita adalah 6.3. So from this you akan dapat 8.51 kilonewton per meter. Check. Betul ke tak?
Betul.
Boleh?
Betul.
Betul.
Okay, proceed. Cepat. Okay, next kita tengok calculate safe weight slab guys. Nah, safe weight slab. Okay, safe weight slab. Okay, special slab. Okay, you tengok kat sini slab dia luas. Ni semua slab ni. Slab. Slab dia luas. So bila dia luas, actually dia punya width dia is width is more than the depth. Nah, width is more than the depth. So kita akan measure dia dalam kilonewton per meter square. Tu special. Slab kita measure dia dalam meter square. Kenapa? Sebab dia punya width lebih besar daripada dia punya depth. Okay, lebih. Okay. So calculate safe weight slab. So once to calculate safe weight slab, kita just consider the slab thickness lah. Slab thickness kat sini given is 150 mm. So in meter is 0.15 times dengan 25. So you akan dapat 3.75. Betul? Check my calculation. Okay, so kita dapat 3.75 km per meter square. Okay, then calculate total dead load of slab. Okay, kalau kat sini saya saja buat step by step. Suruh calculate dead load dulu. Okay, tapi kalau dia tak minta you calculate dead load dulu, terus calculate design load. So actually this one already covered in this. Okay, so calculate total dead load of slab. Okay, siapa nak bagi tahu kat saya kat sini? Total dead load of slab, kita nak consider apa ni? Total dead load. On slab kita ada apa? Apa dead load on slab? Apa dead load yang ada on slab? Bagi tahu? Apa yang kita consider as dead load? Slab. Lah ni cerita slab je guys. Total dead load. Safe weight. Okay, safe weight slab. Kena faham. Total dead load of slab. Kita cerita about slab saja. Pasal slab. Slab yang kita consider as dead load, satu safe weight slab. Lagi
Floor finishing.
Yes, floor finishing. Ni saya kata you kena faham. Sebab apa? Tadi saya kata dah. Atas slab dia ada safe weight dan dia juga ada superimposed dead load. Nah, so safe weight slab. Superimposed dead load is floor finishing here. Ni given floor finishing. Itu yang you nak kena faham tu. Nah. So total dead load maksudnya kat sini safe weight slab plus dengan floor finishing. You betul yang ni, you betul lah bawah. Okay. So safe weight slab just now kita dapat 3.75. Floor finishing given 2.0. So the total of dead load for slab is 5.75 kilonewton per meter square. Okay. Nah. Then calculate design load of slab. Kita ada rumus tadi 1.35 GK plus 1.5 QK. So GK is dead load. Tapi kita kena tengok GK is characteristic dead load. So characteristic dead load sekarang ni kita pakai yang ni lah, total dead load lah. Nah, jangan ambil safe weight saja. Sebab kita ada floor finishing. Tu tolong ingat. Nah, so GK adalah 5.75 plus 1.5 QK. QK kat sini dia bagi imposed load. See, dia bagi imposed load 2.5. So berapa you dapat guys? Kata dapat berapa ni? Berapa total dia? $11.51. Betul ke tak?
Betul.
Okey, kilonewton per meter square. Settle. Boleh nak? Semua nak? So kat sini je saya ingat. Atas slab saja yang ada imposed load dan atas slab saja yang ada superimposed dead load. Tolong ingat yang tu. Nah? Okay guys, next kita akan sketch load diagram on beam A1 sub 12. Okay, we will sketch load diagram on this beam A112. Okay, what is meant by load diagram? Beban, gambar rajah beban. Okay, gambar rajah beban di atas beam. Okay, it means what are the loads that this beam support. Okay, what are the loads that this beam support? Okay, just now we just identify the types of these two panel slab, right? So the left one we got two-way slab. Okay, two-way slab. Okay, because of this slab is square slab, so all these four beams will support the load from this slab equal. Okay, in triangle shape. Okay, then we draw the arrow to show the load parts of the slab to the beam. Okay, guys, clear? Okay, then for this slab, we identify as one-way spanning slab, right? So as one-way spanning slab, we divide LX side into two parts and draw the arrow to show the load parts of the slab to beam. Okay, guys. Okay, now what the other loads on the beam? Okay, what are the other loads on the beam? Okay, tadi kita just calculate apa? On this A1, okay, on this beam, kita juga ada brick wall, right? Kita juga ada brick wall. Okay, then yes, of course, beam tu sendiri ada dia punya safe weight. Okay. So, load diagram on beam A1/12 means kita nak sketch kita nak sketch all the loads yang ada on this beam. Okay, first, okay, buat satu line untuk beam. Okay, then kita name it kat sini, this one, A11 and A12, A11, A12. Okay, just sketch the diagram without stating the value. Okay, and the span of this beam is 6 meter, right? Okay. So let's sketch the load on this beam. Okay, we start with what? Safe weight. Okay, we start with safe weight. Okay, start with safe weight. Safe weight, of course, along the span of the beam, right? Okay, so safe weight in UDL, uniformly distributed load. Beban teragih seragam. Okay, means this load are distributed along the span. Okay, for 6 meter. Okay, this one is beam. Okay, next we have what? Next we have brick wall. Okay, brick wall also constructed along the span of the beam. Also constructed along the beam. Okay, this one is brick wall. Okay, next. Okay, next we know this A112, okay, this beam A112 also support this slab in triangle shape, right? Listed as W1 and another side is W2, one way. Okay, so let's sketch the load diagram also. What color? Yes, okay, blue. Okay, set W2 first. Okay, W2 first. Okay, W2. Okay, this one is W2 slab. Okay. Then another one we have W1. Okay, W1 is two-way slab in triangle shape. So just draw triangle shape. And don't forget to draw the arrow of load parts. So this one is slab referring to W2. Okay, you just sketch this this diagram to represent the W1 and W2. Sorry, this one is W1, right? W1. Okay, this is how you sketch the load diagram on beam A112. Okay, guys? So what is load diagram? It means you have to draw all the loads that beam support. Okay? Okay, next we are going to calculate total design load on beam. Okay, total design load on beam, jumlah beban reka bentuk di atas rasuk. Jumlah beban reka bentuk. Maksudnya kat sini, total load. Just now, kita tahu on beam A112, there is safe weight of beam, design load of beam, design load of brick wall, design load of W1 and also W2. Okay, this one is W1, right? Okay, this one is W1. Okay, so W1 actually design load. Okay, first, I state the value for each design load first. Guys, write down the design load value for each element. Design load beam. Okay, design load beam. We get 2.97 before. Okay, then we have design load brick wall. Okay, design load brick wall, check. Design load brick wall 8.51 kilonewton per meter. Okay, then we have design load slab 11.51 kilonewton per meter square. Okay, correct guys? Okay, so all these are design load, and we know this beam support design load beam, design load brick wall, and also design load slab in W1 and W2 shape. So the value of design load for slab 11.51 is not the actual value for W1 and W2, right? Okay, as you can see here, it's not the total design load of slab distribute to beam A112. There is a way to get the value of W1 and W2. Okay, so how to get W1? So W1 actually is two-way slab. Okay, two-way slab. So W1 is equal to design load slab times width area of triangle. Okay, design load slab times width area of this triangle. Okay. So referring to this referring to this figure, we know the length is 6 meter and the height of the triangle is 3 meter. Okay, separuh. Okay, separuh daripada side dia kan. Itu kan sebab 45 degree bahagi sama rata. Okay, 3 meter. So design load slab 11.51 times width area of triangle. So area of triangle 1/2 times width base. Base dia tadi 6 times width height of triangle is 3. Okay, so from this kita akan dapat what guys? 103.59 kilonewton. Okay, see? Here the unit is kilonewton. Okay, the unit is kilonewton. Why? 11.51 kilonewton per meter square cancel off 6 meter, 3 meter, right? So we get in kilonewton unit. Okay, settle for W1. So remember for triangle slab, how to get the value of design slab? W1 equal to design load slab times width the area of triangle. Okay. Next, we have W2, right? So W2 is one-way spanning slab in UDL. Okay. Okay, another one is W2. Okay, we have in UDL shape, uniformly distributed load. Okay, this one is uniformly distributed load, W2. Okay guys, I forget to tell you, this triangle shape we call as UVL. Okay, this one is UDL, right? Okay, this one is UDL, uniformly distributed load. Okay, this one is UVL, uniformly varying load. Varying load. Okay, betul tak? Varying load. Okay, beban teragih pelbagai. Kalau kita tengok kat sini, the load are distributed uniformly. Sama je kan sepanjang length beam tadi. Tapi UVL ni load diagihkan secara tak sama. Kalau kita tengok sini the value tak sama. Okay, the value of distribution load tu tak sama. That's why we call this as uniformly varying load. Okay, back to design load of W2. Okay, W2 in UDL. Okay, in UDL. So how to get the value of W2? So W2 is equal to design load. Okay, this one. Okay, W2. Okay, so how to get W2? Design load times with LX. LX 2 divide by 2. Because of what? We divide LX side into 2 parts, right? Okay. So here design load slab times with LX over 2. Because it half of the LX. Okay. So design load is 11.51 times with LX is 2 over 2. So here we have 11.51 kilonewton per meter. Okay, so we just get W1, W2, design load B, and also design load brick wall. So we can total up all that value. But before that, okay, calculate total design load on beam A1 stroke 12 in kilonewton, guys. In kilonewton. So in kilonewton, let's see our design load beam in kilonewton per meter. Design load brick wall also in kilonewton per meter. W1 already in kilonewton and W2 in kilonewton per meter also. Okay, so what are we going to do is to convert all these three load into kilonewton. Okay, how to convert? It's very easy. Here, for example, this beam. Okay, this beam in kilonewton per meter. So how to get kilonewton? We time with the length of the beam. Because of what? All the loads are allocated along the span of beam for 6 meter. Okay, guys, remember here. Okay, so total design load. So total design load of design load on beam in kilonewton equal to, we start with design load B, 2.97 times with 6 plus 8.51 times with 6 plus W2 11.51 times with 6 and plus 103.59 already in kilonewton unit. So from this, we have 17.82. Calculate, guys. Plus 51.06 plus 69.06 plus 103.59. Okay. And the final result is 141.53 kilonewton. Okay, guys. So, how to get total design load on beam in kilonewton? Make sure all the loads are in same unit. Okay, so how to convert it? We times with the length of the beam. Logically, because of what? All the load are on that beam. Okay, guys. So, that's all for analysis load on beam.